we are actually dealing with the power and energy signals, and we are solving the problems wherein a signal would be given to us, and we have to identify that signal as power signal or energy signal. If it is power signal, we have to calculate the power of that, and if it is energy, we have to calculate the energy. Fine. In the last session, we had seen this particular problem wherein x of n was given, a discrete signal was given, okay, and that discrete signal is cos pi n. Understand? Now, this cos pi n is periodic or not is the question that we were discussing. Fine. Now, this cos pi n looks like this, okay, wherein see we have patterns, repeating patterns. At 0 we have 1, at 1 we have -1. Okay, again this 1 -1 is repeating. See, 1 -1, again this 1 -1 will repeat, and if that is repeating for infinite number of times, then this would become periodic. But this is non-periodic. This is non-periodic. How do we say this is non-periodic? Because see here, this cos pi n is ranging only from -4 to +4. If the range was infinity, then we could have called this cos pi n as what? The periodic signal. But here, since the range is finite, this comes to the category of what? Non-periodic signal. And obviously this is deterministic. Cos pi n, this is mathematically expressible, and it's very much deterministic because we can determine all. If it is cos pi n, if n is 0, cos 0 is, if n is 0, it is cos 0, and cos 0 is 1. See here. And if n is 1, it is cos pi is -1. For n equal to 1, see here, for n equal to 1, it is cos pi, and cos pi is -1. And for n equal to 2, it is cos 2 pi, and cos 2 pi is 1. So that means for all even numbered samples, you will have samples equal to 1. And for all odd numbered n's, whether it is minus or plus, okay, you will have -1, samples of amplitude -1. Everybody is okay with that? Fine. So that's why this cos pi n can also be written as -1 to the power n. Why it is -1 to the power n? Because -1 to the power anything which is, if n is even, -1 to the power of even number would be a positive number. That means it would be 1 if n is even, it would be -1 if n is odd. So that is what is this cos pi n. Understand that? So that's why we consider this cos pi n, which is going from -4 to +4, but instead of considering it as cos pi n, we consider it as -1 to the power n, and that -1 to the power n looks like this. Okay, and it is going from -4 to 4. Fine. And what is this -1 to the power 2n? And is this 2n is there, right? This 2n is even numbered power or odd numbered power. For any value of n, this power would be even numbered. Why? Because 2 is there. Any number multiplied by 2 would give you an even number. So in that sense, this power -1 to the power -1 to the power 2n, what we have. So this 2n would always be an even number. So this is always an even power. So -1 to the power -1 to the power of even number, okay, would always be 1. So that's why this particular thing can be written as this. Now you have to sum this one. So you have 1 at n equal to -4, you have 1 at n equal to -2, you have 1 at n equal to -2, you have 1 at n equal to 0. Likewise, for every n ranging from -4 to 4, you have 1. So how many such samples are there of amplitude 1? There are 9 such samples. So that means 9 times you are adding 1. That's why it is 9 joules. Fine. There is another way of dealing with it, which seems tedious at this point. Okay, we'll come to this later on. I just gave you this method wherein I wanted to go from 0 to 8. Instead of going from -4 to 4, I wanted to go from 0 to 8. Okay, so this is another way of dealing with it. Okay, this will help us when we are dealing with infinite series, infinite range signals. Okay, so let's not bother about that now. Let's take the same signal now. See here, and since it is non-periodic deterministic, we call it as energy signal. That's why we calculate the energy. Okay, suppose if we take the same signal, let's say I'll take the same signal. Okay, let me write that. So everybody take down this signal, ninth one. Okay, we'll take the same signal, but see how it is going to be different. Okay, yeah, how it is going to be different. Everybody just look at this. We have now x of n given as cos pi n only. It's cos pi n only. Okay, and see the range of this cos pi n. It is this and 0 elsewhere. So can you tell me what is the difference between this signal and this signal? The range is the difference. Here in the ninth problem, I'm taking cos pi n only, but this range is n greater than or equal to 0. If I say n is greater than for n greater than or equal to 0, okay, so what is the range of this? So this x of n is cos pi n from 0 to infinity. Understand that? Since this is cos pi n from 0 to infinity, we can say this cos pi x of n is what? A periodic signal. It's a periodic signal. It is non-periodic because it is finite in length. It is finite in length, that's why it is non-periodic. Okay, since it is periodic, so this is a power signal, and since this is a power signal, we have to calculate the power. So let's calculate that. Everybody just take this down. In the solution, let's give reason. You can just take a note. Signal x of n in problem 8 is what? Non-periodic because this is just for you, because the range is finite. This is one. Signal x of n in problem 9 is periodic since range is infinite. Here it is going from C n greater than or equal to -4 less than or equal to 4. This is the range. Here what is the range? N ranging from 0 to infinity. Understand? Okay. So let's say that in the solution now. Since x of n is periodic, okay, it is a power signal. It's a power signal. Is that okay with you? And since it's a power signal, we have to calculate the power. Okay. Therefore, power is given by 1 by n. Okay. Summation n ranging from 0 to n minus 1 x squared n. Where what is n here? Where n is the fundamental period. Fundamental period. So can you tell me what is the fundamental period of cos pi n now? Can you work out and tell me what is the fundamental period of cos pi n? See the previous problem, you will understand. You just see the plot, the sketch of cos pi n. I've told you, I'll do that again for you. Okay. the same cos pi n, but it goes from what? 0 to infinity. Fine. So what I'm sketching is cos pi n. At 0, it is 1. At 1, it is minus 1. At 2, it is 1. At 3, it is minus 1. At 4, it is 1. At 5, it is minus 1. And this continues till infinity. Okay, so this is 0, 1, 2, 3, 4, 5. Okay, so this is 1 at all even numbered n's, and this is minus 1 for all odd numbered n's. Okay, so this cos pi n can also be written as what? What is this? So this is cos pi n. Cos pi n can also be written as minus 1 to the power n, because it is 1 for minus 1 to the power 2n. Sorry, because I want the power to be even. Oh, what's happening? No, it's wrong, right? Yeah, minus 1 to the power n. For odd numbered n, it is minus 1. For even numbered n, it is plus 1. So that happens with this mathematical expression. Now, can you tell me, seeing this, what is the fundamental period? Anybody, can you comment on this? What is the fundamental period of cos pi n? Because that is required here to calculate the power of the signal. Comment on that. So these two samples, a sample at 0 and sample at 1. Okay, we have 1 minus 1. The same samples would repeat again. 1 minus 1. 1 minus 1. Okay, that's why the fundamental period is what? 2. Okay. And fundamental period is n equal to 2 samples. Okay, therefore our P can be written as n is 2, so it is 1 by 2 summation n small n ranging from 0 to n minus 1, capital N minus 1 it says, so it is 2 minus 1, mind you. Okay, and x squared n. So what is x squared n? X squared n is x of n, we have understood it to be minus 1 to the power n. So we'll write it as what? Minus 1 to the power n whole square. Okay, so this reduces to be what? So it's 1 by 2 times n equal to 0 to 1 minus 1 to the power 2n it becomes. Understand? So how does it look like? How many samples are there now in this particular summation? There are 2 samples. One is minus 1 to the power 0th sample plus minus 1 to the power 2, because for this is x of 0, this is x of 1. X of 0 would be 2 into 0, it's to the power 0. It is 2 into 1, so it is power 2. So what would this be? Okay, anything to the power 0 is 1, and minus 1 to the power 2 is 1. So it is half 1 plus 1. That's why the power is given to be 1 watt. Is that okay with you? Now take this problem number 10, and the problem is like this: x of n equal to cos pi n by 2. Okay, now you have to see whether this is power or energy signal. And if it is power, calculate power, and if it is energy, calculate energy of that particular signal. Okay. Can you do this yourselves? See which how to say whether this is periodic or not. First of all, so if they have not given us the range, if they have not given us the range, means it is understood that the n takes all the possible values by default. Okay, if they say it is n greater than or equal to 0, then it is infinite range. Okay, if they say n greater than or equal to say -4, less than or equal to 4, then it is finite range. Or it can even be this n greater than or equal to -infinity, less than or equal to plus infinity. So that's happening here. If nothing is given by default, it is this. Everybody understand that point? Okay, so in that sense, n will take the values ranging from -infinity to plus infinity. So this is an infinite signal. But is this infinite signal periodic is the question, because not all infinite signals are periodic. The signal could be infinite, but it need not be repetitive in nature. Such things will also happen. But periodic signal would be repetitive in nature and would be of infinite length. Is that okay with you? Fine. So we have to check whether this is periodic or not. And what is the test for periodicity of this signal? Comparing with cos omega naught n implies omega naught is what? What is omega naught? It's pi by 2. So this omega naught is pi by 2. Now, can we express this omega naught as rational multiple of 2 pi? Yes. So if I say it is 2 pi, then it would be 1 by 4. Understand? And this is in the form what? This is in the form 2 pi into m by n. Understand that? Where n is the fundamental period. Okay, so let's make this comment. Since omega naught is rational multiple of rational multiple of 2 pi, okay, x of n is periodic with fundamental period equal to fundamental n equal to how many samples there? Anybody? How many samples it is periodic with? It is periodic with n equal to 4 samples. The denominator of this rational number would give you the fundamental period of this particular signal. Understand? So since this is a periodic signal, okay, we can say x of n is a power signal. Is a power signal. Understand that? So therefore, what are we calculating? We're calculating the power. Fine. And what is that given by? It is given by 1 by n times summation n ranging from 0 to capital N minus 1, because since we are dividing it by n number of samples, okay, so we need to have n number of samples in this summation. Understand that? So it is n minus 1. Let me write that properly. Yeah. Fine. Now it is x squared n. Fine. Now can we sketch cos n pi by 2? Cos n pi by 2, because if I have this x squared of n as cos n pi by 2, then it would be difficult for me to find the summation. So that's why what did we do in the previous problem? Though it was cos pi n, I express this as minus 1 to the power n, isn't it? So is it possible to do it like that is the question. Or at least if we can see that what the value is going to be, then it would be of help. So for that reason, so let's go and sketch this. Sketching is not actually required, but if we sketch, the things would be clear to us. Understand? So what we're doing is cos pi n by 2 we are sketching. At 0, what is cos n pi by 2? Anybody? At 0, n is 0, so it is cos 0. So cos 0 would be
1.
Okay. At n equal to 1, it is cos pi by 2. And what is cos pi by 2? Cos pi by 2 is 0. So this is 0. At 0, it is 1. At 1, it is 0. At 2, what's happening? At 2, it would be what? Cos pi. Because cos pi 2 by 2. So it would be cos pi. Cos pi would be minus 1. So at 2, it is minus 1. At 3, it is 0. At 4, it is what? What is it? Again, it is 1 at 4 because it would be 4 pi by 2. So it would be cos 2 pi. Cos 2 pi would be 1. At 3, it is 0. At 4, it is again 1. Understand that? So this is how the things look like. Fine. So let's consider just one cycle. One cycle is from where to where? From here to here. I've told you, see, from here to here, it is one cycle. The same thing happens after this. It is 4. At 5, it is 0. At 6, it is what? Minus 1. At 7, it's again 0. 4, 5, 6, 7. This is what is happening. The same thing repeats. Understand that? So, n is equal to 4. After every 4 samples, the same thing would happen. Therefore, power can be given as what? There are 4 samples that we need to take care of. Therefore, power is given to be 1 by 4 times summation n ranging from 0 to what? 3, because it is n minus 1. Okay, 0 to 3. So let's write it as cos n pi by 2 whole square. So now let's see what is cos n pi by 2 for 3 samples. 1 by 4 times. Now when it is 0, it is 1 squared. When it is 1, it is 0 squared. When it is 3, sorry, when it is 2, it is minus 1 squared. Is this understood, everybody? So I'm just going to give values to this. Okay, when you go on giving values to this, you will see cos 0 would be 1. Okay, so this is cos 1. So let me write that. This is x squared of 0. This is x squared of 1. This is x squared of 2. Understand that? So this is how the calculations would be. So how did we come to know whether this is 1, 0 or minus 1? Through this. Okay, with that. Therefore, what is the power? So power would be 2 by 4 and it would be 1 by 2. So that's 0.5 watts. Fine. So if you understand these many problems, you can solve any problem. Okay. So we'll take some more exercise as assignments and we'll try get into that. So it would be more clear to you. So if you have any problems, you can ask me now. If you have any problems, you can ask me.